In this video, we're going to discuss how to solve problems that require us to convert between grams and particles. And just a quick refresher, remember, the word particles can refer to either atoms, if we're talking about just single elements like carbon or helium or something, or it can refer to molecules, which we know are multiple atoms bonded together. So something like carbon dioxide or water with multiple elements bonded together. So this will require us to use Avogadro's number and molar mass as a conversion factor in order to get our units to cancel to solve the problem appropriately. As always, problems start the same way. Identify our givens and our unknowns. So the first question asks, how much would a sample of 1.2 times 10 to the 24th atoms of helium weigh? So we're given 1.2 times 10 to the 24th atoms of helium, and we want to know how much it weighs. Well, weight we know is in grams. We're trying to figure out the mass. Okay? So let's go ahead and start with our given. 1.2 times 10 to the 24th atoms. And now we got to do our conversions. So, well, what's the first conversion that I'm going to need? Well, since I have atoms in the numerator here, I know I'm going to need to have atoms in the denominator here. Well, what's my conversion factor with atoms? It's always Avogadro's number. So I'm going to need 6.02 times 10 to the 23rd atoms is the same as 1 mole. Okay? But I can't, I'm not done yet because the problem has asked me to convert to grams, to weight. So I need one more step where I'm now going to use the molar mass to convert from moles to grams. Molar mass of what? Well, the problem is talking about helium. So I'm going to need to look at the periodic table. I'm going to need to have 1 mole of helium in the denominator, and I'm going to need the mass of helium in the numerator. If I check the periodic table, the mass of helium is 4 grams. So there's my setup. I know I'm done because what I have in the numerator here, grams of helium, is what the problem is asking for. I can cross out my moles, cross out my atoms. Now I just got to do the simplification. But quick, small reminder, since these exponents, 23rd and 24th, are not the same, we need to do something that will allow us to make them the same. So when I lower this exponent to the 23rd, I need to move the decimal point over 1 place to the right. So what that's going to leave me with is 12 times 10 to the 23rd times 1 times 4, everything in the numerator, divided by, see everything in the denominator, 6.02 times 10 to the 23rd times 1. Why is that helpful? Because my 10s to the 23rds cancel now very easily. I'm left with 12 times 4 divided by 6, which is going to give me about 8 grams of helium. Boom. Again, we don't want to get into the trap of just memorizing, does it moles go first, does atoms go first? We just want to start with what our given is, and then using our knowledge of conversion factors, think about what has to come next. So let's do one more problem together. How many molecules are present in a sample of O2 that has a mass of 60 grams? So if you feel comfortable, go ahead and give it a shot first. But what we're going to do is look at our given, 60 grams of oxygen, because it's listed here, and we're trying to solve for molecules. So let's start with our 60 grams of O2. Okay, well, what's going to need to come next? Since I have grams of O2 in the numerator there, I'm going to need grams of O2 here. And I know whenever I have grams in the denominator, that means I'm going to have 1 mole, the molar mass of oxygen if I check the periodic table. Oxygen has a mass of 16, but since I have 2 atoms of it, it's going to make it 32 grams. Again, that's from your periodic table. But I'm not done because the problem is asking for molecules, not moles. So I use Avogadro's number. 1 mole of oxygen is the same as 6.02 times 10 to the 23rd molecules. Why do I have to use the word molecules here and not atoms? Well, we're talking about O2. There's more than one atom here bonded together. So that's why we use the term molecule. So now we go ahead and do our conversions. Grams of O2 cancel, moles of O2 cancel. So we're left with, if we rewrite this all, 60 times 6.02 times 10 to the 23rd all divided by 32. So remember, leave the 10 to the 23rd off to the side till the very end. Otherwise, just go ahead and do the math. 60 times 6 divided by 32 is going to give me about 11.25 times 10 to the 23rd molecules. And let's just make that clear. This should be 23rd. There we go. Cool. Grams of particles, either direction, using our conversion factors for practice.